Class, this video is going to work through some of our homework, and I'm going to go ahead and say these are all word problems. This is from pages 373 and 374. I'm not working all of them at this point. I certainly will, but in this video I'm going to work a few selected problems. So the number in yellow next to the printed text, that corresponds to the actual homework problem. So the ones I work will not go in order, but that number will coincide to the actual pages on your book, page 373 and 374. So let's start off with this first equation, this first problem, if you will. And it says the sum. When we think sum, we have to be thinking addition. Two numbers. That means I need to choose two variables. I'm going to use x and y to represent the two numbers that I do not know what they are. That's equals. It says their difference, there's difference, that's going to be subtraction. Oop, there's is again, that's equals. And then what am I supposed to do? Find the two numbers. In other words, I want to find x and y. Well, here's our rule when we deal with system of equations. Now later on in algebra you'll get to three equations, but that's because they're going to give you three unknowns. In pre-algebra, we stick to two unknowns, x and y. So if you have two unknowns, you've got to have two equations. Just try to lock that in your mind. Two unknowns, I need two equations. So our first step is to find our first equation. So I know that I'm dealing with x and y, and the sum, that means I'm going to add these, is or equals 20.5. That's my first equation. Well, as I said, I need two, and I'm still dealing with the exact same equations, or excuse me, the exact same unknowns, but this time I'm dealing with a difference, and that is subtraction. When I subtract these two numbers, I'm left with 6.5. Now, hopefully you recognize that this is an elimination problem, because here I have opposite coefficients for my y value. So when I add, I end up with 2x is equal to 27. Let's go right up here. 2x equals 27. I'm going to divide both sides by 2 to isolate my x, and I get 13.5. So my x value is 13.5. Well, let's go ahead up to, let's just call this as step number 3. And let's do 13.5 plus y is equal to 20.5. All I did was substitute a 13.5 in for x in this equation. I'm going to subtract 13.5 from both sides and get y is equal to 7. So what are my two numbers? 7 and 13.5. When I add those two numbers, I get 20.5. When I subtract them, I get 6.5. All right, let's keep going. Let's look at a little bit harder of a word problem. Tadeo volunteered at the library 6 times. Now that's an important information. We've got Tadeo, and he's volunteering 6 times as many hours over the weekend as Dylan. So we've got two people here, Tadeo and Dylan. Together, they volunteered. Together, that's an important word. That's addition. They volunteered a total of 14 hours. So what if we were to do this? We need to decide our variables. Now, we've got two unknowns here. There's two things that we don't know. I'm going to use x and y. And why don't we let x equal Dylan, all right, the number of hours that Dylan works, and y, let's let him represent Tadeo. And so we know we have two unknowns. That means we need two equations. So what's our first equation? Well, it tells us that Tadeo, or y, equals 6 times that of Dylan. So that's going to be y equals 6x. Now think through this logically. If Dylan, which is represented by x, works 1 hour, then that's 1 times 6, and so Tadeo would work 6 hours. If Dylan works 2, that's 2 times 6, or 12 hours. And so that's telling me that I have it written down correctly. Tadeo is working 6 times as many hours. I need a second equation. It says together they volunteered a total of 14 hours. X plus y equals 14. So those are my two equations now. Now hopefully you see that this is a substitution problem. Since y equals 6x, I will just replace y in my second equation with 6x. So my new equation would be x plus 6x equals 14. I'm going to combine like terms, so that's 7x equals 14. Divide everything by 7 and get x equals 2. So here, Dylan, we know that Dylan worked 2 hours. So step number 3, well, what about Tadeo? Well, I know that he represents y equals 6x, or y is equal to 6 times 2. If we substitute that 2 in, so he worked 12 hours. And there's your solution. He's working 6 times as many hours as Dylan. Dylan worked 2 hours. Tadeo worked 12 hours. All right, let's go ahead and look at problem, if I can get it to pull up. Number 3. Tiana placed 2 orders for flowers and bushes. The first order for 24 flowers and 6 bushes, the total of the first order was $144. Let's just stop right there. We know we have 2 orders, and we're dealing with flowers and bushes. So why don't we just say that X is flowers and Y is equal to bushes. Now let's stop and think through this. The first order was for 24 flowers. All right, there's 2 unknowns. That means I need 2 equations. We need 2 equations. So equation number 1. First order was for 24 flowers, so 24x, and that's plus. We're going to add those 2. And 6 bushes. The total of the first order was $144. Let's go to our second equation. The second order was for 18 flowers, and, there's added again, so that's going to be plus 3y, and the total of the second order was $90. What is the cost of each plant? So I want to know the value of x, and what is the value of y. All right, so from here, I have a system of equation. When I look at this, this is an elimination equation, and I want to eliminate the y, because all I'll need to do is multiply the bottom by -2, because that'll give me a -6 here, which is the opposite of this +6. And so let's work through this. Let's go ahead and just rewrite our first equation. We lose the $sign there for now. I'm going to distribute the -2, which gives me -36x minus 6y is equal to a -180. All right, so now I have a large addition problem. I'm going to go ahead and change colors again. Those 2 will cancel. This is going to give me a -12x is equal to, let's look, that's -36. Divide everything by -12 and get x is equal to $3. So what's the cost of a flower? Well, it's $3. And let's go ahead, let's do a step number 3 here. We need to figure out the cost of y. Let's use, well, I don't know, let's use that bottom equation, 18 times 3. I'm substituting that 3 in for the x here, plus 3y is equal to 90. All right, so as we work through this math, 18 times 3, that's 54. So that's 54 plus 3y equals 90. Extract 54 from both sides, and that's 36. So divide both sides by 3, and you get y is equal to $12. So that's your solution. Your solution, if you wanted to graph this, these 2 lines would cross at a point at 3 and 12. Now these are your 2 answers. Now, one thing that I haven't been doing is, what if we check this? Let's just come up here and check it. Let's use that top equation, 24 times 3 plus 6 times 12. Does that equal 144? And yes, it does. 24 times 3 is 72, plus 72, yes, that equals 144. So I do feel good about my solutions. All right, it's a multi-step problem. I beg of you on these, just take them one sentence at a time. You have to start here, decide what variables you're going to use, decide what those variables are going to equal. Know that it's a system. If you have 2 unknowns, you need 2 equations. Use the first well, the second sentence there to calculate, or to determine, I should say, your first equation. Go on to your next couple of sentences to figure out number 2. And once you have your system, solve accordingly. All right, I'm hoping this is starting to make a little bit of sense. For this video, this will be the last one we work. At a farmer's market, Amar, purchased 4 jars of salsa and 3 cucumbers and spent a total of $12.25. And then we have Dylan. He purchased 1 jar of salsa and 2 cucumbers and spent a total of $4. Now wait a minute. Why are they introducing a third person? Dakota purchased 1 jar of salsa and 5 cucumbers, but notice they didn't tell you what Dakota spent. That's actually the question. So we have to work with Amar and Dylan, find out what we're going to call them X and Y, what they equal, and then use that to determine what Dakota spent. All right, so why don't we do this? We're going to use X and Y. Let's see here. Salsa, we'll just use salsa for X. Cucumber for Y. Now let's start looking at our first equation. We know we have 2 unknowns and we need 2 equations. So Amar purchased 4 jars of salsa, so 4x, plus, there's the and, that's a plus sign, plus 3y is equal to $12.25. We need equation number 2. Dylan purchased 1 jar of salsa, that's x, plus, I'm getting the plus from that and, 2y is equal to $4. And I'm going to show the decimals just to kind of keep the pattern going there. So now I have 2 unknowns, 2 equations, and I stop right there with all my verbiage, and I solve for x and y. Now when I look at this, I think this is a great elimination problem, and I'm going to eliminate the x because I can multiply the bottom times -4. So let's just rewrite 4x plus 3y is equal to 12.25. -4x minus 8y is equal to -16. All right, that's one large addition problem. Let's change colors again. Those are going to go bye-bye. That's -5y is equal to, let's see, go up to 13. That's $3. That's $3.75. Well, don't forget the sign. That is a negative. Now, I started to forget that, but then what I did was I looked at it and I said, wait a minute, I can't have a negative value here. And that, because I was going to be dividing by a negative, a positive by a negative. That results in a negative. That was my clue that I needed to look back up. Oh, I forgot my sign. It's just that easy to do. Divide everything by a -5 and you get y is equal to 75 cents. So what's a cucumber cost? 75 cents. Let's come up right here, I guess. When you do step number 3, what does x equal? Well, let's use that bottom equation. X plus 2 times 0.75 equals 4. So that's going to be x plus 150 equals 4. I'm going to subtract 150 from both sides and get x is equal to $2.50. All right, so I'm not done yet, but now I know what x and y equal. Now I go back to Dakota. And what did Dakota do? Let's come down here and do a step number 4. Dakota, let's see, for Dakota, 1 jar of salsa and 5, there's the and, that's a plus sign, cucumbers. And what did it cost? There's my question. What is the result of that? So I substitute $2.50 in for x, 75 cents in for y, and then do the math. What does that actually equal? Well, it's $6.25. That's Dakota, and that's the answer to the question. All of this other work, this, our first equation, our second equation, deriving y or calculating y, then going up here and calculating x, all of that, those multiple steps all went together to allow us to the final step, number 4, plug it back into the equation that we were given, well, we were given right here for Dakota, and then solve for what Dakota actually spent. So guys, I know these problems are challenging. They are true multi-step problems, but I do hope this video helped. Thank you.